Did you know there is gold inside the Pi Zero 2W? In this video, I'll review the Pi Zero 2W, talk about its good points and about its downsides. I'll tell you where the gold is. We'll ask about this in our free Pi Zero 2W giveaway at the end of this video, so be sure to pay attention to it. I will also show you some cool projects people are using the Raspberry Pi Zero series for. Get inspired and stay on until the end of this video for an important tip how to get the most out of your Zero 2W. And last but not least, did I mention your chance to get a free Pi Zero 2W? Let's take a look at the Pi Zero 2W comfort set you can order from our online shop pizero.de. I've put a link to our shop into the video description. Here's the Pi Zero 2W itself. Along with the Zero W and Zero, it is the smallest Raspberry Pi ever made. Okay, I'm not counting the Pico here. Basically, the Zero series is all about being small, in space and in price. The original Zero, the $5 computer, was given away for free on the cover of the MagPi magazine. The Zero 2W is a $15 computer. Realistically, it's going to be a bit more expensive, as you will need some accessories, add shipping and local taxes. And it packs a punch for these $15. Most notably, it's 5 times faster than the previous Zero W. Before I show you the accessories, let's take a deep dive on its features and ports. The Zero 2W has the usual 40-pin GPIO header for Raspberry Pi heads. You will need to solder it yourself, or you can pick up a Zero 2WH with pre-soldered header from us. The link is in the description. Then we've got the microSD card slot. The most recent Raspberry Pi OS is already compatible with the Zero 2W. If you already have a microSD card with a system on it and it doesn't work, you will probably need to upgrade it. Check out our blog post on picockpit.com how to upgrade Raspberry Pi OS to work with a Zero 2W. A normal size HDMI port doesn't fit on the Raspberry Pi Zero 2W. To keep compatibility with the previous Zero generation, Raspberry Pi is continuing to use a mini HDMI port here. The Pi 4, as most of you probably will know, uses micro HDMI ports. Thus, adapters you bought for your Pi 4 or Pi 400 will not work with a Zero 2W. This means another adapter or a special mini HDMI cable for most people. There are two micro USB ports here. One is for the data, that's the one which says USB next to it. This is a USB 2.0 port. And the other one is for plugging in the power supply. It says PWR in. There's a couple of interesting points to mention here, especially to people who haven't used the Zero W before. The obvious one is that you can't plug in a normal USB device into such a port. You got to use, you've guessed it, another adapter, a USB OTG adapter cable. OTG, by the way, is just short for on the go. This will give you a full-size USB port. So far, so good. But did you know that you can actually also use the Zero 2 as a USB device itself? I'll talk about some projects which do this later in the video. The cool thing is that you will then only have one cable for data and power. Next up, we have the camera port. Using this, you can attach a Raspberry Pi original camera or any other Raspberry Pi compatible camera. Since the Raspberry Pi engineers had to cram that port in there, you've got to use an adapter cable for it. By the way, there's no display port on the Pi Zero 2W as on its bigger siblings. Simply no space. Also, we don't have an Ethernet port. There's only wireless networking on the Raspberry Pi Zero 2W. Let's talk about this. The 02W has WLAN 802.11bgn. It's 2.4 GHz WLAN, no 5 GHz on the 0 series. If you need 5 GHz WLAN, you'll have to use an external Wi-Fi adapter, or you'll have to switch to the Pi 4. It also has Bluetooth 4.2 and Bluetooth Low Energy, or BLE. This is an upgrade which allows up to 2.5 times faster communication over the low energy link. The 02W uses the same tried and true PCB trace antenna design. Right next to it is a landing pad for a U.FL connector. We are probably going to see some modifications with an external antenna as soon as the 02W is in the hands of people who are wizards with a soldering iron. Finally, the WLAN chip is inside a metal shield. This is important for so-called modular certification. So for companies who want to use the Raspberry Pi 02W inside their own products. This allows companies to spend less money and time on getting the products certified in international markets. If you want to use a Raspberry Pi 02W inside your product, please talk to us. We can support you with this. Let's take a closer look at the brains of a 02W, the RP3A0-AU. After the Pico, this is the second chip to bear the Raspberry Pi logo. Many of you have heard the term SoC, a system on a chip. The Pi 02W is a so-called SiP, a system in package. You see, the 02W doesn't have enough space to host an extra RAM chip next to the CPU. On the previous 0W, the RAM was sitting on top of the SoC in a so-called POP, package on package. In the case of the 02W, Raspberry Pi have designed a custom package for these two silicon chips, where the RAM is sitting on top of a SoC. And this is where the gold comes in. The AU in the name of a chip, RP3A0-AU, stands for aurum, Latin for gold. Raspberry Pi wanted to make sure that the chips are very durable, so they went for gold instead of copper for the connections between the RAM and the SoC. So indeed, there is a tiny amount of gold in each Pi 02W. Remember I told you that the new Raspberry Pi 02W is 5 times faster? The same SoC which is used in the Raspberry Pi 3 Model B is used in the 02. We are speaking about 4 Cortex-A53 cores. This allows you to get a feeling for the power of a new chip. On a side note, the Pi 3B will still be a bit faster than the 02, at least if you don't overclock the 02. This is due to better thermal management on the Pi 3B. On the newer 3B models, a metal enclosure is used for the chip, allowing heat to dissipate more effectively. If you are looking for maximum power out of a Raspberry Pi, for example to run it as a desktop replacement, you should choose the Pi 4 series instead, which is about twice as fast as the Pi 02, and of course has other nice features, like USB 3. All this additional CPU power of a 02W comes in handy when using Raspberry Pi OS. It boots up significantly faster, about 3 times faster, applications start faster, and the whole interface feels snappier. It's also great when you're using the Raspberry Pi 02 as the brains of your project, whether it's a robot or a motion detection system, a small Pi-hole server, or whatever. The SoC's GPU is of course the tried and true VideoCore 4, which gives you buttersmooth Full HD 1080p video playback. Let's not beat around the bush and get to the biggest disappointment on the 02W. The RAM is still 512 megabytes. Reason for this is simple. 1 gigabyte of RAM physically doesn't fit in a single plane in the new package and would have to be stacked. Doing a third layer in the package would have been much more expensive, and thus we wouldn't have had a $15 02W. Remember, Raspberry Pi really cares about price and affordability of its products, so they go for compromises. The limited RAM is the biggest downside of a 02W in my opinion. I'll discuss in a little bit what it means for applications running on the 02. Let's turn the Pi 02W over to inspect the back. There are no electronic components here on the back of a 02W. That's what helps drive its price down after all. But there are still a couple of interesting other things. There is a data matrix code here. This is the 02W CPU serial number. Again, this is a feature most likely to be of interest to industrial users who want to identify the 02W in the field. Also, there are these solder test points, many of which have little inscriptions next to them. We have several ground test points, 3.3 volts, 5 volts, 1.8 volts, USB DP and DM, which are the two differential USB 2.0 data lines. Also we have TV, which is the composite video output, and run. Connect run to a ground pin to reset Raspberry Pi. Previously, these were available on unpopulated headers on the 0W, but on 02W they had to move them to the back because of space constraints. This concludes our tour of the board itself. To sum up, the biggest change is the increased CPU performance. 5 times faster than a 0W if you are able to use all 4 cores in your application. Remember, some applications can only make use of one core at the same time, but Linux will at least be able to run other processes on the other cores, though there's definitely a boost there. The biggest downside is still only 512 megabytes of RAM. Finally, the 02W has some changes which are useful for companies building it into their products. Let's talk accessories. First of all, you would of course insert a micro SD card into the Raspberry Pi 02W. This one is 64 GB and already has a Raspberry Pi OS on it. This is the mini HDMI adapter, which you can plug into the mini HDMI port of a 02W to be able to insert a full-sized HDMI cable into it. By the way, Raspberry Pi does not encourage similar solutions for the Pi 4's micro HDMI sockets, as the mechanical strain would be too big. To plug in USB devices, we use the micro USB OTG adapter. For example, I like the Logitech K400, and this is the receiver of this keyboard and touchpad combination, which I can plug in right here, and then it goes into the micro USB port, which is titled USB on the 02W. Finally, to connect a camera to the 02W, we need to use this camera adapter. Here we have a Raspberry Pi camera, for example, and here we have the original Raspberry Pi Zero case. As you can see, the case has 3 different lids. One of them is solid, one of them has an opening for the GPIO port, and one of them is meant to house the camera. Inside the case you will find a small camera adapter, which we will be using to mount the Pi with the camera into the case, and rubber feet to be attached at the back side of the case. First of all, let's take care of the camera. We have to open the clip at the back side to remove the cable and mount it. Also remove the little protective shield which is here in order to open the lens. Put it in the right way. Needs to face into the opening and then click it into place. Be careful not to exert too much pressure and to not touch the lens while mounting it. Afterwards you can insert the cable into the camera. And close it. After that, we are going to attach the camera to the zero, also by opening the flap and inserting the camera connector. Now the two parts are connected and we can click the zero into place in its case. Note that the SD card should be mounted at this point, because otherwise you will need to open it again. The zero clicks into place, as you can see, and then we can close the lid and we have a nice little security camera. A good alternative case to the official Pi Zero case is the Flirc case. The Flirc case has the big advantage that it acts as a heatsink, and you can even mount a camera with this case. Then you will be using the long camera adapter and it will go in this way. We are now ready to connect the power to the Raspberry Pi 2W. As always, remember to use a good quality power supply. This one is a Raspberry Pi original power supply, which we are shipping with our kits. Plug the power right in here, and remember, if the LED does not light up, first check the micro SD card whether it has a valid operating system. The big upside about all these accessories is that the Zero 2 follows the Zero form factor very closely. Most accessories you've already purchased for the Zero should just work with a Zero 2, including the original Pi Zero case and the Flirc Zero case. Let's talk a bit about the downsides and limitations of a Zero 2W before we get to the example applications, because it's kind of related. I'm speaking once again about the limited RAM. For people doing small applications where the Zero 2W is an IoT node, or for example recording video or retro gaming, this should not be a serious problem. But it is for web browsing. Chromium will crash or freeze. YouTube won't fully work on it, at least not out of the box. I'll share a tip at the end of this video, because there is something you can do about this to make the web browser behave. Debatable downsides are the lack of Ethernet, which you can add using an external USB adapter, or no analog audio out. Again, these are easily handled through USB or GPIO peripherals. I personally don't consider the missing run and TV headers a downside, but there might be some people who do use them. Finally, there are some accessories which will not be compatible with a Zero 2, as they use rather special features, like a certain position of the solder test points. Your mileage will vary on these, and I'm sure that there will be new Zero 2 versions of these accessories on the market pretty fast. Let's get to the software applications then. The Zero 2 will probably go into many applications where currently the Zero is used, and enable them to go faster and more smoothly. I've picked a couple of project ideas for you. Many people use the Zero to drive displays. For example, there are some people who do Magic Mirror projects with the Zero. Other people use the Zero with tiny e-ink displays or desktop indicators, for example for the Bitcoin exchange rates or as stock tickers. I've personally combined a Zero with a Pimoroni blinked LED strip as a status indicator. Well, it was supposed to become one, but right now it's just bringing some nice rainbow colors into my life. Another popular application is wherever you need to display information to people, like prices of sandwiches, train schedules, or maybe even video playback. It's just like a sign, except that it's digital, and therefore people in the know also call this digital signage. Some TVs have enough power on their USB ports to allow the Zero 2W to run directly from them. Thanks to the Zero having built-in wireless, you even don't need to run any additional network cables, and are always up to date with your sandwich prices. Of course, we also have video input on the Zero too, so there are many camera applications as well. Using the HQ camera from Raspberry Pi, you could hook up telescopes, microscopes, or just regular lenses. So anything is possible, from watching the stars, watching the microbes, to just watching your neighbors. Speaking of video surveillance, this is not only useful on your property but also in factories. Pi Zero 2 could be mounted together with a camera to monitor the product quality while the products speed by on the conveyor. We might look for things like whether the widget has holes in the right places. Thanks to the Neon extension and the newer processor of the Pi Zero 2, these image recognition applications will be significantly faster than on the previous generation. If you want to look into this topic, search for OpenCV and deep learning. Or speak to us if you need professional support in this area. Yes, this could also be used to distinguish cats from dogs. So the Pi knows when to block that cat flap at your front door. I've got to admit it. I've forgotten to tell you about a big and unique upside of the Zero so far. A big additional advantage of the Zero series as compared to the bigger Pis is its light weight, at least for drone applications. The additional processing power of the Zero 2 is very welcome for drone applications. You can build your own autonomous drone using a device called Autopilot. For example, autopilots which support the Pixhawk standard. Here you could even combine vision applications with the help of a camera port. For example, you could do precision landing by identifying your marked landing spot. The X marks the spot. Finally, retro gaming fans will be very happy about the increased CPU speed. More CPU speed means of course that you will be able to play games of more advanced game consoles. You should be able to play NES, SNES, Sega Mega Drive, PlayStation 1, ScumVM games, and many more. Do you remember Monkey Island, one of my favorites? The Pi 4 is still the optimal choice for retro gaming due to its performance. For example, N64 games will not work at reasonable frame rate on the Zero 2. But the Zero 2 allows you to do really cool hacks. For example, some people have built the Zero W into their gamepad. Other people have built Game Boys off a Zero W. There's even a commercial kit you can get to do this. The second most bizarre project in the retro gaming area I've seen has been to put the Zero into a gaming mouse. This was done to be able to play Doom with it, without any external keyboard. This was in fact Eben Upton's idea, and the staff of Magpie took him up on it. Here you can see the result. Let's talk about a cool Linux hack which actually makes this possible. Have you heard of the thing called USB gadget mode? It's a possibility Linux offers, and it allows you to turn the Raspberry Pi Zero 2W into a USB device rather than a USB host. It works because the USB port is directly connected to the SoC, not using a USB hub as on the bigger Pis. For example, the Zero 2 can be turned into a mass storage device, showing up as a thumb drive to the host computer, or an Ethernet device. Just imagine the possibilities of what you can create with this. I'll throw a couple of ideas out here. How about building your own gamepad, which can automatically play a game or has other advanced functions? This will surely give you an edge up on other players using just regular run-of-the-mill gear. How about a panic button? This way, when your boss suddenly comes, you can quickly open what you're supposed to work on and hide YouTube. How about a virtual flash drive, which will show different files depending on the secret pin you enter? So how does the Zero 2 compare to the Zero W in real life? Here we have the Pi 0W. As you can see, the CPU load is somewhere between 10% and, well, with small peaks, about 25%. For desktop only, running basically nothing running besides Pi cockpit. We can also check the temperature that looks like. So as you can see, the temperature is at around, let's say, 30 to 40 degrees centigrade. So about 35 degrees. Let's switch back to the CPU load view. And now we'll start Pingus. Pingus is a Lemmings clone. Anyone remembers Lemmings? And now we'll check how the performance of the Pi. As you see, it hits 100% CPU load immediately, as Pi cockpit is showing us. Now let's resize the window to the right dimension, and also we'll print the FPS, the frames per second, here. As you can probably hear in the background, the sound of Pingus is not smooth, and that's because the CPU is overloaded. It's at 100% of 0. Let's rescale that window. Okay, that about is right. The CPU load stays at 100%. The frame rate is about 5 frames per second, 6 frames per second. That's not too great. Let's see how it performs in level. Entering the pyramid. Still at 6 frames per second. So let's see. So about 6 frames per second. Now the Pi has been running a while. Let's check out the sock temperature. That increased. Yeah, so you see that it's going up, right? Because the CPU is heating. And actually, if I touch it, it's still it's warm to the touch, so it's not too hot. Now the room I'm inside at the moment, actually you've seen here this small area where I touched the sock. It went down a little before it's now starting up to go again, because I took out heat energy from it. The room which I'm in is quite chilly at the moment, so actually the sock temperature in a normally heated room would probably be higher. Right, so as you can see, the game is barely playable on a 0. In fact, it performs surprisingly well, I'd say. You know, for those 5 frames per second, it does look rather smooth still. This might look different on a game like Mario Super Kart or something, but for Pingus, I'd say it's a rather decent performance. Of course, you can use Pi cockpit to also compare other applications like a web browser. Well, maybe let's just do one quick browser check and see how the CPU load performs there. This was Pingus, and now it's loading the browser. Right, so here you go, there's the browser window. As you see, this is all rather, well, you rather need a lot of patience in order to be able to use the Pi Zero in a desktop style kind of application. It's loading the Raspberry Pi homepage. Well, here it is. And a CPU load is consistently at 100%. Right. Remember, this is just one core running on the Raspberry Pi Zero of the first generation. So we do need to understand that the performance is rather limited, and as one Raspberry Pi engineer put it, you shouldn't use the Zero for web browsing. Of course, he's also referring to the Zero 2, but I believe the Zero 2 is a bit more suitable for web browsing than the Zero itself. Let's take a look at the Zero 2 next. W running at about, as you can see here in Pi stats. This is, by the way, again, for anyone who missed it before, this is PiCockpit, our free Raspberry Pi web interface. It's free for up to 5 Pis and allows you to do to administrate, to control, and to monitor your Raspberry Pis remotely, free of charge for up to 5 Raspberry Pis. As you can see here for the Pi Zero 2, the CPU load is staying consistently at about 1 to maximum 2% when it's idling, whereas it was about 10% for the Zero. Mind you, PiCockpit does need a little bit of CPU power in order to generate these graphs. So if like to get the data and send it to PiCockpit, if PiCockpit wasn't running, probably on the Zero we'd get lower idling value, maybe 5%, maybe 7%, who knows. On the Zero 2, maybe instead of 1%, maybe something like 0.5%. But yeah, that's it. So again, we have a stock temperature of about 38 centigrade. We're going to return to that later. Right now, we're going to start Pingus again. Pingus is, as you remember, our Lemmings clone. And we should get the sound now. I'll put in the frames per second and I'll resize the window again so that we have identical testing conditions. But off the bat, you can see that it's already at 39 frames per second. If you remember, the Zero gave us a much lower value, much lower frames per second value. The music, by the way, is not perfect, but smoother than for the Zero of the first generation. Let's start another level. Also, another thing, as you can see, the CPU load is significantly less, so we're not hitting 100%, we're about 35 to 40% CPU load. Let's try Pyramid and see how the level plays. Now this does look much smoother. If you look at those little penguins running around, I think after trying for a while, I'll probably finally be able to lead the penguins to their right destination. Yeah, you can basically see that it's pretty smooth right now. So it's pretty playable, and the CPU doesn't hit the 40%, so you can imagine that things like Super Mario Kart or other games might also be playable on it. Good for retro gaming. Let's have a look how the temperature developed at the same time. So as you can see, we started out at around 40 degrees centigrade, and now we're at about 54 47 roughly, right? So if I touch the sock, it's warm. It's starting to be a bit too warm. By the way, you see here where I touched it, there's a drop. But it's still okay, so it's not painful to touch it. I'm going to do another little demo now by opening a web browser. So let's check that out. And you can of course also see the socket temperature falling when the CPU thinks it will not get any more work to do. But there it was mistaken, because now we're going to hammer it with one of the most demanding applications known to computers, which is your humble web browser. You notice that the browser itself was loading much faster than under Zero, and also the actual rendering of the website is faster. It's actually tolerable fast, so you could very well imagine using this for showing train times, or basically just showing any kind of digital signage stuff on top of it. Let's have another look at the CPU load. As you can see, this was where we were playing around with Pingus. So there we were at around 40%. Now, as I said, the browser is a much more demanding application, but still we're at about below 80%. So keep in mind that this is a CPU load across all cores. So if an application is not able to use all cores in parallel, then you might not see the CPU load hit 100%, but the operating system will be much smoother, everything will be much smoother, and browsers are very, very well designed pieces of software, so they are mostly using all cores when displaying the information to you. Right, so there we see it. The Zero 2 is a pretty tolerable device using the browser. I will now show you another little feature of PyCockpit, which is power off button. So you can power off your Raspberry Pi using your web interface. This concludes our tour of Zero 2. Now, next up, we're going to take a look at the Pi 4 and how it stacks up against the Pi 2. Pi 02 is the Pi 4. As you can see, the CPU load is at around 1% to 2% when idling, not that much different from a Pi 02. Let's have a look at Pingus. Again, I'm going to set up the frames per second and resize the window so that we have identical comparison options. Frames per second are actually, and interestingly enough, down from the Pi 02. Here we have about 22 frames per second. If we go to the level sets, desert, we stay at about 26. So if you remember, the 02 had about, I think, about 39 frames per second, or at least 33, so that's a surprising result, which should be noted here. About 26 frames per second, so it's still very playable, and quite honest, I've seen comparisons, and I mean the Pi 4 is a more powerful machine, but some of its power also comes from things like out-of-order execution, and also you have to keep in mind that it has a quite different architecture for the graphics units, because it has two HDMI ports, obviously, so that might also have some impact on the frames per second rate. Again, with the CPU load, we are actually seeing something like 30% here, 27, 29. So this is, if I remember correctly, a bit lower than it was for the 02, but in the same neighborhood. So I'd say the 02 is a pretty powerful machine. That's the main point of demonstrating this. Then we can have a look at the sock temperature actually here. So it's slowly creeping up from 40 to about 50. Yes, and I can feel that the SoC is hard. In fact, because it's metal, it transports heat much better. As you see that drop there, that was due to my finger touching the sock, or the enclosure actually of the sock. It's more hot to the touch because it's metal. That's something which is an interesting observation. Now let's the frame rates again stay at 24. Let's have a check with the web browser and how that performs. I'm going to switch back to the CPU load. I think that's more interesting. Let's try the browser. I'm going to show you two websites on this one. I'd say on the Pi 4 the browser feels even a bit snappier than on the Pi 02. It does take up a lot of the CPU, so that's our shop where you can purchase the 02, buy0.de, and also we're going to take a brief look at YouTube. YouTube is a very demanding application, specifically for the browser. So what we'll do is I'll actually play a video. So you can see the browser works, the performance is okay, and it's smooth, right? So there's no problems there. Also resizing works without problems. Tearing is due to the capturing, it's not due to the Raspberry Pi's output. And in PyCockpit you can observe in parallel that the browser didn't go, or the browser didn't push the Pi 4 beyond 100% or to 100%, because beyond is not possible on a CPU, right, without overclocking at least. So the verdict is, do get a Pi 4 if you need maximum performance for browsing and you want to have a decent browsing experience. But the 02 is fine for many other applications, because it actually has a fighting chance as compared to the Pi 4. As we've seen in Pingus, in some applications it might even be performing better due to probably some specific technical reasons. Right, let's shut down the Pi 4 again using PyCockpit. by the way, this is one application which I also wanted to show you briefly, the PyDoctor. You'll be able to run all kinds of tests. Specifically also see certain information like the serial number, CPU frequency, CPU voltage, SD card manufacturing date, and other things, or see how much space is in use. All of this also, of course, for the 02. In this case, we see that it's a Pi 4 with 2 GB of RAM, which this was run on, manufactured in the UK. Right, now back to shutting it down. This concludes our tour of the comparison of 0 versus 02 versus Pi 4. Comment in the comments below what your favorite is and what model you're going to take to purchase. And stay tuned for a couple of more performance tips for the 02. I'm now going to show you how to overclock your Raspberry Pi 02W in order to get even more performance out of it. Keep in mind that in order to be able to do this, you will need adequate cooling for the SoC so that it does not throttle. For example, a FLIRC Zero case or an active cooler. We do have both in our shop by zero.de. And also, depending on the particular silicon chip you've got, you might be able to overclock it more or less. We'll try a recipe I've found to be useful. To do, click on the Raspberry Pi, click on Run, and type in the following command: sudo pcman-fm. This will open the file manager as a root user, which you can recognize by this little sign here. You're in a super user mode. And then we can launch an editor from, if you select the boot folder here in under root, the boot folder, and then scroll down to config.txt. Right click and open it. Well, we might as well use Geany for it. Scroll down to the very bottom where it says all, and directly below paste the following lines. Over voltage equals 4, ARM reg equals 1300, so we are overclocking it by 30%. Core reg equals 500. This part about the core frag is for the video core, so we are overclocking both the CPUs and the video core, the GPU. We can click on save. As you see, the file was saved, and now of course we've got to reboot. You should of course observe your system and notice if it still, well, boots first of all. If it doesn't, you might want to use either an additional computer to boot, to edit the file, or to Right, we're back at the desktop, and now I'm going to open the web browser. I'm going to open youtube.com again. We should see that it performs a bit faster. The SOC is still barely warm to the touch. So as you can see, it's still running a little faster. Now I'm going to show you how to increase swap size. That is the secret trick to making YouTube or browsing in general a bit more pleasant and stable on the 0W. Albeit it will not be faster, keep in mind, because we are going to use the SD card as an additional storage space for things which actually belong in the RAM, because they need to be accessed quickly, but it's better than the browser freezing, isn't it? So first of all, close down all applications which you have open. Open the terminal. and type in sudo dfis minus swap file swap off. By default, Raspberry Pi OS ships with 100 megabytes of swap space. What we're going to do is we're going to increase it to 2 gigabytes of swap space. So now we will edit sudo nano etc dfis minus swap file, and there's a swap conf s1 conf swap size. You might want to put a comment in front of it using Ctrl K, Ctrl U 2 times. You can actually keep the old line in Nano. Here we type 2048 because we want it to be 2 gigabytes. We remove the comment sign, and we type Ctrl O to save and Ctrl X to quit. Now the next thing to be doing is to initialize the swap file. We do that by typing sudo dphys minus swap file setup. As you see, it has generated a swap file of 2048 megabytes or 2 gigabytes. And the next and last step is to turn on the swap. Sudo dphys minus swap file swap on. If we run htop, we will now notice that we have a swap file size of 2 gigabytes, as you can see here. Now let's see what the browser does with this new configuration. Let's keep an eye on the memory usage. As you see, the swap file is filling beyond the 100 megabytes which Raspberry Pi provided initially. And again, we're going to open a new tab in order for us to be able to demonstrate how real use cases actually work. As you see, as compared to the previous attempt to actually run and load a video, this time the video starts and plays even though there's a lot of buffering going on. In total, we're using more than the 512 megabytes of RAM which the Raspberry Pi has. And after all the other content on the website loaded, it seems to play in a tolerable fashion. So this is the magic trick which you can use in order to make browsing on the Pi Zero 2W more pleasant. Simply increase the swap. Keep in mind that things will be a bit slower, and probably you would really want to use a Pi 4 for desktop use, but this is what you can do in order to make things work. Browsers are very heavy memory users. What is better than a cheap Pi Zero 2W? A free Raspberry Pi Zero 2W, of course. There are two ways to get one with a little help from our side. First, if you're a blogger, journalist, or YouTuber, we want your blog post or video. Reach out to us for a free sample. We have a limited amount of these samples available for you. Just write to us at support@pi3g.com. Second, comment below what project you would like to make with the Zero 2W and where the gold is. We will raffle off 2 Pi Zero 2W comfort kits, 3 basic kits, and 5 Pi Zero 2W each month until the end of this year 2021. You can get your Pi Zero 2W from an approved Raspberry Pi reseller near you now. If you want, check out our own shop at buy0.de to get yours today. If you got value out of this video, give it a thumbs up, subscribe to our channel, and share it with your friends. Thank you for your attention.